Jason Chan from the Netflix engineering team. Jason's a cloud security architect, has been in the security industry for a number of years, and is going to tell us some great things about working at large scale.
Thank you, sir. Hey, everybody. Thanks for coming in. Thank you. Thanks, everybody, for coming in. There's a lot of really good sessions, so the fact that you came in and wanted to hear a little bit of my chatter is very much appreciated. What I'm going to do is a little bit of a kind of a case study. If you were at Zane's talk or maybe the Twitter guy's talk yesterday, it'd be kind of in that vein of, I spent many years as a consultant, and one of the things as a security consultant, then customers would always want to know, like, they're always happy to get guidance and recommendations, but they would always ask, well, what are other people doing? What are our competitors doing? So that's kind of what this is in the spirit of, kind of information sharing. So Netflix, if you haven't heard of this, or if you're not aware, it's basically a video subscription service. We started out in the late 90s doing DVD by mail, where you just go to the website and choose a DVD. We'd send it to you, keep it as long as you want. And then a few years ago, we went to streaming video, which is the same experience, except you just hit play and we stream it over to your device, to your TV. So this is me. I'm the cloud security architect. What I do there is I manage a small team, and we're responsible for application security, product security response, infrastructure ops, basically anything that's running in our cloud environment, which is basically anything on the website, anything you would interact with as a Netflix user. So before that, I was led the security team at VMware, and as I noted, spent many years as a consultant for a few different places. So this is, you can see by my scheme, I'm not really a design person, slide-wise, but I saw a few cats, so I did want to add one. This is a grumpy cat. So there's challenges, right? So there's quite a lot of really good advice out there. I just cite a few of these. There's a lot of really good books, websites. Microsoft is, very pioneering in terms of secure software development. But it's not clear what exactly works. This is, I like this slide. It's from a Forrester report from a couple years ago. Basically what they did was they asked like a couple hundred people who work in AppSec, what works the best? Like, which practices provide the most value? And really, there's source code management, code reviews. It's not really clear that anything is a big winner. This is obviously subjective. So when you then throw in these new things like DevOps and cloud and Agile, where we don't really have a body of knowledge on that yet, I don't think, or kind of experience as an industry. And then you add in the politics of your own organization, whatever tech stack or legacy you're dealing with. It's not really clear. That's why Grumpy Cat was grumpy. So there's all this good guidance, but what do you do given your own individual challenges? So to kind of set that up, I'll talk a little bit about Netflix engineering, how we're set up. And so we're in the cloud. This is part of the title, so I wanted to give a little run through here. So Netflix runs its service out of Amazon Web Services, which is a public cloud service, infrastructure as a service. We built basically a platform as a service on top of Amazon, and that's how we operate our service. There were a few reasons we went to the cloud. In 2008, we had a pretty big outage where it actually impacted mailing DVDs for about 3 days for a number of customers, and customers were mad. And at that same time, we were kind of kicking off streaming, and the executives were kind of thinking, oh, geez, we have to think differently about availability, and is managing our own data centers, is that really something we want to be in the business of? And that kind of leads into, this is Werner Vogels, the CTO at AWS, and they have this phrase, undifferentiated heavy lifting. So Netflix is an entertainment company. It's video, it's streaming, it's all about personalization and recommendations. Handling things like storage and networking doesn't really add anything. So if AWS can do it for us, we're happy to let them. And then there's also the Netflix culture. The Netflix culture gets talked about a reasonable amount in like HR and recruiting circles, MBA students and stuff like that. It's pretty interesting. It's an interesting place to work. But in terms of how it relates to the cloud, the key part of the culture is we kind of want to get the company out of the employee's way and let you move as fast as possible. So everything the way that we structure the culture and operations is very much in line with that. There's a lot of things that we don't do that or you would see in a typical organization. And then just, if you think in terms of picking a DVD and mailing it versus actual streaming, you can imagine that there's quite a lot of difference in bandwidth requirements and CPU and storage. This is just a report you might see. So during our peak usage time, about a third of the traffic in the US is actually streaming, Netflix streaming. So it's a pretty large scale service, and we want to be able to grow it. So the cloud is really kind of a natural fit for us. So we're around about 99% in the cloud. There are a few things that we run out of the data center. So on the way to the cloud, we didn't just say, okay, well, we're running in the cloud now. This statue is meant to kind of represent our old way we managed the web app. So it was this monolithic Java web application that was deployed once every 2 weeks. Engineering teams owned little pieces of that. They checked in their code, and it went to production every 2 weeks. So on the way to the cloud, we exploded that model to where if you previously owned a library or a jar file or some service, that now is a network service. It's a network-based service, and that's how it's a distributed system now, and that's how things interact. And then what that means from a deployment perspective is that you now control the schedule that you deploy your service on. If you want to do it every day, that's fine. If you want to do it once a month, that's fine. You're not in the way. You're not tied to anybody else's release cycle. Also, you've probably seen a couple of these pictures. Also, we changed the organization. So we typically had this separate dev and ops organization. Now we moved to, I guess, DevOps, or sometimes we'll call it no-ops, because we don't actually have a separate operations organization. Everyone involved with creating and deploying and running the website is in the same team. It's just engineering. We don't have a separate ops team. This is just a little bit, some numbers. Actually, I think we just announced, we just hit like 30 million paid subscribers, tens of thousands of systems, hundreds of engineers and apps. This is just some metrics from this week, about 250 deployments and tests a day and about 70 in production. So deploying code at Netflix is very instrumental to the way we approach security. And if you've seen some of these other talks, I think you'll kind of see why. So I'm going to go through it just a little bit. So this is a real common graph at Netflix. It doesn't even matter which app this is. And you could probably surmise this if you're familiar. So there's a lot of people who watch movies and TV at prime time when they're off of work. It's 8 o'clock at night. There's not as many people that watch TV at 3 a.m. And then you can actually even see the day differences, Saturday and Sunday in the middle, where it kind of bumps up in the afternoon because you got kids at home. You just multiply this, and the old way was, if you have this kind of usage curve, you paid and you provisioned for what that peak was year round. If you multiply this across the dozens of different apps that actually comprise the Netflix, you can see why, well, hey, the nature of the cloud is actually really, really interesting in being able to scale up and down. So that's really our solution to that, is load-based auto-scaling. And this is a feature of Amazon Web Services. So the goal with auto-scaling is that the number of systems you're running at any given time matches what your load requirements are. The load per server is constant. So if your load average should be 10, it's always 10. And the only thing that differs is the number of servers that's managing that load. And it happens without intervention. And that's the auto and auto scaling. So you set a policy, you say, I want my cluster to be between 5 and 200 systems, and you just stay between there based on load. So the results are you're always adding or removing nodes. At 5 p.m. we're starting to add, we're starting to ramp up. At 3 a.m. we're ramping down. And everything has to be exactly the same as what is in the pool already. So for us, what that means is every time we make a change, a code change or a config change, we actually push an entire new cluster of systems. We don't make any changes, any incremental changes to existing systems. So deploying has to be super easy, because if you say, well, hey, I need to modify like a one-line config file, and I have a cluster of 500 systems, if you don't make that easy, then people will work around it and you'll have other problems. So this is just a real brief walk through our pipeline. We use Perforce or Git for source code. You check in a change. You use our CI environment, continuous integration, to run your build. And what we do is we package the code and config as an RPM file, which is a Linux packaging format. And we have a Yum repo, which is just a kind of package distribution. So at this point, once your build is run, all your code and all your config is in an RPM. We have an infrastructure called the bakery, which takes our base image, our base Linux image, and then adds on whatever your app-specific code was. And then it bakes an AMI. So AMI is Amazon Machine Image, which is the VM template that's ready to launch. You add that with your cluster configuration and your policy, and now you have running systems. So basically what you say is, use this template based on these load characteristics. Always make sure my cluster has between 10 and 500 servers. And Amazon takes care of the rest. So it's super easy to get through this. It may look a little complex, but we have a number of tools that make it really easy. We have Asgard, which is a cloud orchestration tool we've open sourced, which you can do it just through a GUI. We have Jenkins, and a lot of people will do automated build and deployment. We have Odin, which is actually a client-side DSL for interacting with the build and orchestration environment for actually pushing code out. And we have a number of teams who are kind of doing some really interesting work on canaries, where basically every code check-in, once it passes your unit and your integration test, it would automatically get built to a canary instance, which would get automatically pushed to production. You can automatically analyze the performance and security characteristics of that one canary versus what's in production. So it's pretty neat. It provides some pretty interesting options for both engineers and security folks. So the question is all the deployment happening in the cloud? Right. So if we go back here, the parts that we have right now in the cloud are so basically kind of the bakery, or actually the Yum repo on out. So we still have our source code for the most part in our data center, but we are looking at ways of pushing that out. So operationally, you can kind of think of what some of the changes would be. You're not making changes to running systems, right? People always say, well, one of the biggest risks is making a change to a running system. And that's why ops people say they don't want to make changes. There's no systems management infrastructure. We don't use tools like Puppet or Chef. Those are good tools, but we don't, since we're not operating in that manner, we don't need that infrastructure. There aren't as many logins to production systems. There's not this notion of a snowflake where every system is just a little bit different than everything else. And we have trivial rollback. I put rollback in quotes because you're not really rolling code back. You're just going to push a cluster that had an older bit of code on it. You're not actually going to make any changes to what's running. And then from the security perspective, you have to think differently. Some things are easier, some things are harder. When you talk about vulnerability management, well, for many years I co-managed this mailing list, patch management mailing list. Maybe some folks were on it. There was always this talks about, oh geez, I got to push these patches out. I got to hit 95%. And these aren't things that you think about in the same traditional way, because you're not going to make those changes. You think differently about monitoring activity on those systems, because really they're just these stateless nodes that are doing whatever task it needed to be doing. File integrity monitoring, again, if you're not changing anything, hopefully FIM should be an easier problem to solve. One of the things that makes it more difficult is forensic investigations, because you got systems coming and going all the time. Well, hey, I got this log message. Well, that system was terminated at 3 a.m. So the org is different. There's DevOps. The architecture is different. The deployment is different. And then what about security? So we've also adapted, and this is kind of what the sort of meat of the talk will be. What I was going to just do is just give some examples, but it felt a little haphazard. So I try to organize it to some degree into these sort of principles that we find some commonality of. These are things that if you kind of keep this in mind, you'll probably be successful. So one of them, which maybe seems obvious, but is integrate. I'll start with it at the organizational level. You want to integrate. So our team is in the engineering organization. It's in the product development organization. It's not like a separate silo, so it makes communication a lot easier. So tooling-wise, we talked about that base AMI and that bakery process of taking the image and adding on your code. So at Netflix, everything is based off of the same base AMI, the same image. So you can imagine, well, if absolutely everything of tens of thousands of different systems is always based off that same image, well, if you concentrate your testing there, then that's going to have a lot of impact. These are just some stats. Again, I just pulled these yesterday. Average age of a running instance is about 24 days. 60% of the instances are less than a week old. So you can imagine if you're trying to get security fixes out there, well, if you can make changes this quick and the systems are this new and are turning over this fast, it's easy to get security fixes out as well. What we do for testing of the base AMI is, the base AMI is managed just like any other package, any other application in Perforce and Jenkins. What we do as a security team is we watch the source code directory where all the config files for the base AMI are, and we just kick off changes we kick off our testing when it changes. We just launch an instance of the AMI and do some vulnerability scanning and other checks. And this is just a screenshot from Jenkins. you just monitor another project. This is the project that our base AMI runs under. So whenever it changes, we kick off testing. This is just an example of a report. So we're not worried about, so it's a different team that manages that base AMI, but we don't have to have meetings or talk about when things are changing. We just watch their job. When they make changes, we take a look. Is there anything we need to worry about? I mean, they create release notes and things like that, so we can dive in if we need to, but this provides a nice way of an automated, just quick check. And that's related also to security packaging. So all of our security tools use the same tool chain as the rest of the engineering team. We store all our config, all our tools in Perforce or Git. We use Jenkins to build all the packages. This is an example from a spec file, an RPM spec file. The RPM spec file just basically defines how an RPM will be generated. This is from one of our web servers. It's a requires line. What that requires line does is it pulls in these different RPMs. So when we want a team to add one of our security tools or something that we do, we just say, well, just add this to your requires line. They add one, one line in, and they automatically get integrated. They automatically load the host hardening package, which is just implemented as an RPM file, our web app firewall agent, OSEC, which is like a host-based IDS agent, Cloud Passage, which is a config assessment and firewalling tool that we've been using. So it's real easy for them to load these on their servers and test and prod. It's quite simple. We do the same kind of thing with static analysis in terms of integration. We make it self-service through the build environment using find bugs and PMD. We're starting to look at some commercial solutions that are a little more security focused. And we use a Jenkins plugin just to display graphs and allow you to kind of drill through the results. And this is just a screenshot of that. So you would have find bugs run whenever there's a check-in or whenever there's a build, and it would give you a sense. You can tie in all kinds of alerting to this kind of thing. The next thing is integration with, I don't know if this is a common acronym or if somebody made it up. It's monitoring, alerting, and notification. And it's important because I was actually in a good talk this morning. Josh and Dan did the symbiotic security talk, and they're kind of this notion of tools that create output and get consumed by other things. And so being able to integrate is really important. That's really important when you're talking about security monitoring and alerting and notification. So there's all these different systems involved, some of them commercial, many of them that we've created ourselves. But what we know is that the standardization is important. So we have this system called the Central Alerting Gateway. This is software we built in-house. And it's one single place that you can generate alerts from. So if you have an IDS system needs to generate an alert, if you have a web app firewall that needs to generate an alert, whatever it is, just send it to CAG, which is the short name for it, and it will generate the alert for you. It's tied into our PagerDuty notification system so that you can automatically handle escalation policies. It's real simple to use, Python, Java, JSON post. It also allows for stateful alerting and some response, which is actually kind of cool. Stateful alerting in that you can have multiple events that are correlated with the same thing, and then response in terms of, hey, if I see this kind of event, we'll kick off a TCP dump or terminate an instance or reboot an instance. You can have that kind of control. And really, when we're looking at commercial tools or where we're looking to build something, it's basically a prerequisite that we're going to plug into this infrastructure because that's what we have available and that's what we're going to use. This is just an example, a code example, real simple Python. You basically you import the module, and then it's super simple to generate an alert. And again, that first thing in quotes, the first parameter, test cluster, that's tied into PagerDuty. So it's going to see, well, who owns test cluster? Which distribution list? What's their escalation policy for a normal alert? Should we page them? Should we send an SMS? Should we email? Should we just log it somewhere else? Related to that, kind of the other side of things is a tool we have called Kronos, which is a timeline system, which is really, really useful. It's both an API and a UI, and it lets you track config changes and deployments. So if I make a deployment, I'll just write an event into Kronos. So now I now have an event in there. And again, anything that we have security tool-wise, when we're making changes, we're going to write into Kronos. So examples, what IP addresses have been blacklisted by your WAF in the last couple of weeks? Oh, it's a simple API query. This is a little bit of the query language. Which security groups have changed today? Security groups are the Amazon notion of hypervisor firewall. So we make sure we write everything in here, and we can easily query it out. And this is for not necessarily alert type things. That's really what the central alerting gateway for. But this is just for interesting events that may be of interest. This is how I got the stats around the deployments per day, those kinds of things, because our orchestration tools, whenever you do a deployment, it writes an event into Chronos so that we know something changed. The next principle, past integration, is really about making the right way easy and secure. I was in the keynote actually this morning where I think it was Michael Howard was talking about crypto and how this is just historically something that's difficult to do and hard for developers to understand. And it's true, it's not something that you should do yourself. So but it turns out when you have a really large web system or distributed system, there's all kinds of uses for cryptography, not just data encryption, but encrypt, decrypt of cookies, signing URLs, data, messages. There's really all kinds of uses for it, and you want your developers to be able to use it properly. So what we did, we created a system called Cryptex, and it's kind of like a multi-layer crypto system. It has a basis in HSM, a hardware security module where we store keys, and we also have a scale-out layer, and it's real easy for developers to use. This is just a little code snippet of encrypt, decrypt. And I think probably the biggest benefit is that all the key management is handled transparently, but you don't have to worry about hard coding keys and that kind of thing. We have a pretty simple, I guess, key sensitivity regime where we say if it's a real high sensitivity key, it never leaves hardware. If it's medium, it can go out to our proxy layer. If it's low sensitivity key, we actually can deliver to an instance and it can do local processing. And the way you make that decision is based on how sensitive is the data, what's the performance characteristics you need, and everything we have access controlled and auditable as well. So what we did there is you take something that is really useful but kind of hard to do right, and you just sort of abstract it away, and then you actually find that people will use it quite a lot. Another thing similarly we did to try to make things easy and secure is cloud single sign-on. When you're in the data center, when you have a web app in the data center and you want to, say, put an admin interface on it, and you want to, say, authenticate against your Active Directory or your LDAP, that's pretty easy to do, right? You just, because you have that network connectivity. When you're in the cloud, when you're in EC2, there is no route from the cloud to your data center. You can't do that kind of querying. There is no LDAP, there is no AD. What we did was we leveraged one login, which is a SaaS SSO, there's a lot of acronyms in there, tool that our IT guys put together to handle things like access to Workday, which is our HR system, and Box, these kinds of SaaS apps. It's one of these things that allows you to use your enterprise credentials. So we just said, well, there's nobody's saying that we can only use those for external SaaS. So we built a real simple filter. We're primarily a Linux, Java, Tomcat type shop. So we just built a real simple filter that integrates with our platform web server to make it relatively trivial. This is just a copy from our web page of, hey, if you add this package, well then now you have SSO on your app. Yeah, I mean obviously there's a little bit more to that, but it's really quite simple to do. This is, I don't know who came up with this. Was this Ronald Reagan or probably somebody earlier than that? Trust but verify. So I mentioned that the culture, the Netflix culture. Our culture, it doesn't really support the idea of a security team that is like the Dr. No, the hammer, this command and control, centralized. That's not a way, an operating model that would be supported or successful. It's just for any number of reasons, but just culturally, it's just not possible to have. We don't do things like change review boards. We don't have architectural review boards. That's just it's not really part of the way we operate. So because of that, there is some trust involved, but then we also have this verification piece. And I guess our centerpiece of this is a security monkey. And I think it was mentioned some yesterday. We have this suite of tools that we call it largely the simian army. So we have the chaos monkey, which will just go through and blast, just kill instances, and just make sure your app can survive it. We have latency monkey, janitor monkey, conformity monkey. When you don't have an architectural review board, and you're not strongly enforcing these things at a certain place, what you have to do is make sure your tooling really supports the inspection of those architectural practices, and that's what these tools do. And SecurityMonkey just handles the security side of that. One of the interesting things about the cloud and cloud APIs is that they make the verification and analysis of a particular configuration really, really straightforward. I know it's not quite an AppSec thing, but if you're in a large enterprise, say geographically distributed, like financials, I remember as a consultant, sometimes you would go into these places and they have hundreds of different firewalls and they'd be different vendors, and now there's actually a whole market segment of vendors that analyze the flows that are capable through these firewalls and what can reach what. And that's impossible to do in a multi-vendor, really distributed environment. With the cloud, with AWS, that's just real simple API call to describe the configuration, and then you write your own analysis tools. And that's one of the things we built into SecurityMonkey. We do other things here, like checking for SSL certificates. What's the cipher? Is it expiring? Again, there's a whole market segment of tools that do that, right? Because everybody's had that outage where a certificate expires. IAM is another AWS acronym. It's Identity and Access Management. It's kind of their user group policy permission. We keep an eye on those things. And then limits also. Limits in Amazon are kind of like the way that you DOS yourself, because every account has a limit on certain entities. Like you can launch 20 instances, and when you try to launch your 21st instance, you're not going to be able to. Of course, our limits are raised, but there are still limits. And we want to make sure that we understand where we are in relation to those limits. And this is just a little screenshot. This is one of the features here. We have this idea of exposure. We have a number of rules and analysis bits that will say, hey, this instance looks like it might not be configured right, or this cluster might not be configured right. We tie it in with Asgard. I mentioned the sort of PagerDuty notification. The way we set things up is that there's this notion of an application, and then that application has an owner. That application is tied into a specific distribution list of how they receive things. So if you own an application and SecurityMonkey finds something wrong with it, we're going to let you know. And that's how all the monkeys work. They'll just email you. So you want to keep your monkey email as small as possible. And this is just a sample of an email that we get. This is just an email telling us that in production, one of our security group rules changed. Kind of the next step that we took from SecurityMonkey was ExploitMonkey. And this is kind of how I got involved with the folks doing Gauntlet, which I don't know if you saw that talk yesterday, but it's a pretty cool testing framework. I mentioned that an auto-scaling group is how we deploy code. So when we deploy code, we build a whole new cluster and push it out, right? We don't make changes to running systems. So when an auto-scaling group changes, that seems like a good time to run another set of security tests, right? Because it's clear something changed. So that's what we do. We just have ExploitMonkey. ExploitMonkey is a generic framework for doing this kind of thing, like monitoring something, and when it changes, do something else. And then again, tie into Kronos and the CAG for alerting and notification and timelining. And this is just a sample email. Hey, I noticed this ASG changed from this version to that version. Now I'm starting a vulnerability scan from this IP address. And it's important that we know which IP address it's starting from, because it's a cloud instance. So we know what it looks like in the logs, our web app firewall. Well, because what we could do with this, if we wanted to, would be to automatically whitelist this IP in the web app firewall to make sure that if you wanted to get maybe a deeper amount of scanning. And then similar to this is the ELB checker, which is the little bit of kind of testing I talked about yesterday during the Gauntlet talk. Amazon has this feature called Elastic Load Balancer, which it provides load balancing across data centers. But what many people don't know is that if you put your app behind an ELB, it's now facing the public. Anybody on the internet can reach it. Doesn't matter what the security group looks like on your instance. So what we found out is that engineers may not understand it. So it's a self-service environment. People can create their own ELBs and push these if they want to. They may not understand the security features, what the right use cases are, or what other security measures or options you might have. So we've had cases where somebody has attached what should have been a private or like a back-end app to an ELB, and oops, it's public now. So what we did with Gauntlet was, well, we have hundreds of different ELBs, hundreds of different clusters. Let's use Gauntlet to try to wrap around this testing. What we do is through our CI environment, we launch an instance with Gauntlet loaded, and it has basically the master list of ELBs. It knows about all the ELBs we should have and how should they respond to arbitrary internet traffic. But right before we do the testing, we pull a new list, right? Because things are changing all the time. And we create separate attack files. These are just simple kind of, attack files are just sort of plain text that tell you how the thing executes. What this test does is just uses the curl feature of Gauntlet, and just to do a real simple test. If I curl this URL, what status code do I get back? Do I get a 200, a 301, a 403, a 401? And then the idea is that we know what the response should be. If it's different from that, that causes a failure and causes some action. So we execute the attacks. Anything new, any new ELB or change config would automatically fail because we didn't know about it. And anything that we did know about that's now responding differently would also fail. And then this is the last kind of principle I want to talk about. And this is really very closely tied with the cloud, is this idea of self-service. This is one of the key cloud characteristics, is that we want to actually have developers do their own thing, right? It's part of the culture, but with exceptions. It's kind of that idea of when you go to whatever your favorite grocery store is and they have the self-checkout. You can go use that all you want, but if you want to buy beer, they're going to get involved. That's kind of how we look at it. Even if it's security configuration, we're going to let the developers do their own thing to the extent where we feel comfortable that they're not going to cause a serious problem. So we do that with security groups, which is the firewall config. We allow our Asgard, this is our open source tool that we built. It allows you to manage your own firewalls, but there's certain things that you can't do. But it handles 95% of what a developer needs to do. They can very simply create a JIRA for any additional changes, and then Security Monkey keeps an eye on things for us as well. That's kind of the general approach there. So takeaway-wise, I guess lessons learned. We run a large service, pushes at a peak about a third of the U.S. internet bandwidth. There's lots of good guidance out there. If you combine that with whatever your own context is, it can help you jumpstart a kind of practical and pragmatic security program. And if you're moving to the cloud, you're thinking about things like DevOps. Well, it's also a good opportunity for security to update itself. And then just last but not least, just integration with your engineering partners. Couple of slides here, references. These are, if you're interested in any more stuff Netflix does, we open source a ton of our platform on GitHub. We have a tech blog where we talk about this kind of stuff. SlideShare, I'll put these slides up there as well. And then other stuff that I referenced is in there as well. What library do we use to integrate with AWS? We're primarily a Java shop. So we take the Java SDK and we built a platform layer. That's part of our platform as a service. So developers don't interact with it directly, but they call our platform. We do have a fair amount of Python usage, and for that we do use Bodo, which is the Python version. So what if because we mentioned we don't change running systems, what happens if you have a 0-day, you have something high risk, you want to get a change out fast? What we do is we traverse that same path. We would make the change to whatever code needs to be made. We'd launch a new cluster of that. And basically the way it works is so if you have, say, a cluster of 500 nodes running the old code, we call that, we have this notion of red, black, push, just because of the kind of Netflix colors. That's the red cluster, that's the old cluster. You bring up the black cluster, which is the cluster with the fix. They're both behind the same load balancer. And whenever you feel like it, you just cut traffic over to the new one. But part of the way that enables you to do that is in the cloud, it's really important to think about statefulness. And all those clusters are completely stateless. So we do have a persistence layer, right? So sometimes you can't just kill systems. And we use Cassandra as our primary cloud persistence layer. So what about these? For those, we have a separate way of updating. So we actually use that same yum process, but these are the only systems that are able to use it in production. So if we need to push patches out, we'll use yum to persistence. There's other things we have like memcache and things like that you can't just kill off. But really the 95% architecture is that they're stateless systems, they can be killed, and that's really what Chaos Monkey helps. And so if we had to make a change to base AMI or a platform component, how do you make sure everything else would work with it? We do have a test environment. Actually, one of the things we enforce, I didn't mention it, but before you can launch code into production, it has to be launched in test first. And it has to be launched via an auto-scaling group. You can't just make a change and go right to production. It actually has to traverse the test environment, and we enforce that through tooling. So you can't just come up with a change. So you actually do have to launch a cluster and test. And then what we try to do is, through that canary process, I mentioned the canary process where every change will automatically launch one instance that may take, it may be one instance out of a cluster of 400 or 800, but it's going to take some traffic. You can analyze how that's performing against everything else. So that's a good way to get that kind of visibility for low impact. Yeah, Perforce and Git are different. Why do they both exist? Perforce was as you can imagine, is kind of the legacy. I'm kind of like, I don't care. I mean, I don't write that much code. But we started hiring people who were like, so we had these people who wrote like, kind of a gateway, a Git to Perforce gateway, and then they just said, we're just going to use Git. So that's how we handle all our open source stuff as well. So we manage I think it's called Git Enterprise or Git Pro, where our IT team manages some of that stuff internally, but all our open source stuff is actually out on GitHub.
So you obviously deal with credit cards. So I imagine that's part of your AWS cloud system. Have you had any challenges dealing with PCI compliance? And because the way you do things are very different from the way it's built.
Right. Yeah, good question. So PCI, that's kind of one of my real big focuses through the end of this year, because I mentioned that we're 99% in the cloud. That kind of remaining piece is the data center, it's the credit card handling. We want to be able to, but part of the problem is our data center is in Santa Clara, California, right? We just released to like Denmark and Sweden last week. We don't want to have, European subscribers' ability to sign up or change their credit card dependent upon data center. So we do want to move that to the cloud. We're kind of working through that now. In terms of, do I envision challenges? Honestly, the biggest challenge I think we'll have will be on the auditor side. Just auditors are probably, they're just not that, like the idea of distributed systems, it's kind of a different, I think it's mostly going to be just kind of education and kind of educating them how things like continuous integration and deployment and, automated analysis are in some ways better than maybe the old way of doing things. But I think it'll be an interesting next couple of months. Oh, we're out of time. Thanks everybody for coming. Appreciate it.